All right, so now we are doing problem number 34 of section 12.4, implicit differentiation. For the demand equations in problem 31 through 34, find the rate of change of Q with respect to P. So we've got P equals 3 over Q squared plus 1. So we're trying to get the derivative of quantity with respect to price, not the derivative of price with respect to quantity. So let's take the derivative. Let's rewrite the top as 3 times Q squared plus 1 raised to the power of negative 1. Okay, so taking the derivative of P, that's just 1. And then we have negative 3 times Q squared plus 1. We're using the chain rule here. And then we're going to take the derivative of the inside function, which is going to be 2Q. And then we take the derivative of the Q with respect to P, so we're going to have dQ dP. This is again an inception problem. Multi-layered, multi-composition problem. Alright, so now we want to isolate dQ dP, so we're going to have dQ dP equals 1 over negative 3 times Q squared plus 1 raised to the power of negative 2 over 2Q. And remember, Q squared minus 1 raised to the power of negative 2 in the denominator is actually the negative of that, the negative exponent of that. So we're going to be left with Q squared plus 1 squared. Put the negative outside, the negative from the 3, so we're left with, and 3 times 2 is 6, so 6Q equals dQ dP. And there you have it, folks. That is the change in quantity with respect to price that we got out of this inverse demand function. Whenever you have price as a function of quantity, it's called an inverse demand function. And even when you have an equation like this and you're trying to find the derivative, the rate of change of quantity with respect to price, you can simply use implicit differentiation. You don't have to completely rewrite the equation. If you're comfortable using implicit differentiation, which hopefully you will be after this section and after this course. And we are done, folks. We are done.